this is a little bit more of a case study approach. Ali Shabbir from GM is going to kind of talk us through their journey and some of what General Motors is working on today to kind of take that next step forward and really put additive to work for them. So welcome, Ali. Over to you, sir.
Hey, good afternoon, John, and thank you everyone for attending. Hope you all can hear me well, and please do let me know in the comments if there's any issues with. So with that, as it was kind of referenced and almost perfectly plugged by Ellen from Ford Motor Company in the last talk, I'll actually be going over a little bit of the US car roadmap that was presented and released around Rapid this year in September of 2021. And those sort of highlight all the challenges that the automotive industry is facing around industrializing additive for use and widespread usage across our portfolio. So with that, I have some slides to share, and I will get into that just in a second. All right, so I hope this is coming through well. Give me a shout, John, or someone if it does. Yeah, looks like it. Okay, perfect. Good. So again, my name is Ali. I'm an engineering group manager at General Motors as part of the product engineering organization in additive design and manufacturing. So my responsibilities essentially span leading a team of application and design engineers that are involved in the use of additive throughout our development cycle on all of our products. So if it's a part on a car, my team would be involved in some way, shape, or form. And why I'm here speaking on behalf of US Car is I was part of the development team represented by Ford Motor Company, General Motors, and Stellantis that put together the roadmap for additive manufacturing as part of the US Car, which is the United States Council for Automotive Research, essentially a consortium, as Ellen had pointed out. And I was one of the participating members that contributed to this, and I'm certainly here speaking on behalf of all the good people that put their hard work and effort into creating this roadmap. So quick overview of our 26 minutes or so left here. The agenda, I'll go over a little bit of the motivation and development that went into creating the roadmap, the content itself and the 4 different swim lanes and some of the challenges that we've identified. And just, I guess, a warning with only 30 minutes for the total talk. I'm not going to get into too much detail about this specifically. The full roadmap is available at uscar.org, and I'm happy to field any questions afterwards in the Q&A or offline should anyone have any specific questions. So what's the motivation behind using additive in the automotive industry? Why would the automotive industry even care about additive manufacturing, as it's been pointed out repeatedly that it is a low volume part manufacturing technology that historically came from a prototyping legacy. I heard money talk, so that's one of the things and one of the reasons why this matters, right? The entire part for automotive is valued around $350 billion a year. And that's just the parts themselves. That's not the tools, that's not the assembly lines that go into it, that's not the software that's involved in the design and the production of the components. This is just the parts themselves. And I know it's an old kind of entrepreneurship and venture capital trope to capture just 1% of a market. But I will reiterate, just think about even 1% of those parts that go into all those vehicles, around 70 to 90 million units a year. And if you were to capture that, that's over $3 billion of just part sales. Then obviously the associated equipment, the associated post-processing, the associated software that comes with that. And a similar angle can be applied to just thinking about on those 70 to 90 million vehicles a year that are produced, and it's projected to sustain over the next coming years. Just getting even 10 small parts on each of those vehicles that meet the rate, the quality requirements, the performance requirements, that is a significant amount of 3D printed parts that can be out in the world and out in real uses. So the automotive industry represents a big, likely untapped potential for market for a lot of the additive world out there. But then also, why does automotive care about additive, right? That was a little bit about why additive should care about automotive. The industry itself is changing very rapidly at an incredible pace. The EV transformation that is upon us, and most, if not all, OEMs are going through this right now, is significantly fragmenting the product market and portfolio that we have today. The volumes that you might have seen in some of the products that can be into the millions of units a year, or at least into the hundreds of thousands, at least initially may not sustain in the EV world. Some of the new product introductions are significantly lower volumes. Some areas are being tested, some markets are being tested, new product platforms are being rolled out with a slower cadence to ramp up. And this all presents an opportunity to do lower volume manufacturing, and also presents a challenge to be much more agile and much quicker to market. The speed to market and agility has never been challenged before like it has now in today's environment. And this puts a lot of pressure on the OEMs and our suppliers to deliver parts, and oftentimes challenging the design and manufacturing status quos that have been out there for years. If you need to deliver a vehicle in 2 years versus 4.5 or 5 years, which is what it may have taken, you have to do fundamentally something different. And that's where additive plays in, along with some of the trends that we're seeing around personalization and customization of vehicles and so forth, that also will play into a lower volume need and drive down some of the time to market and the capital requirements that we have. And then finally, I'll say this, that the automotive OEMs, both here in North America, as represented by US Car, but even around the globe and with our suppliers, are pretty unified in this point of view that additive can be game changing and meet our needs. But there's still much opportunity to be pursued to truly make it ready for automotive use. There's needs around having it more widespread adoption, around technology, around materials, around process efficiency and sustainable use to really bring this into production and fruition. And that will fundamentally touch a lot of the business models in additive, the machine architectures, the materials, the application workflows, the softwares, the manufacturing floor integration. These are all challenges that we hope to capture unified thoughts around and present here in the US Car roadmap. So like I mentioned, I don't want the entire message to get lost or diluted. So the full report is available for consumption, but I will walk through a few of the sections here in a brief second. So just touching on, the timeline that it took to get here, starting sort of mid last year with some planning meetings and workshop discussions among the US Car members, to the publication earlier this year in April, and then formally releasing in September at the Rapid Conference. So that was sort of the timeline and the work groups that went into the creation of the roadmap. So the first swim lane of the roadmap captures a lot of the thoughts and requirements around design. As we all know, designing for the manufacturing process, any manufacturing process, not just additive, is paramount to the success of that part. And it's no different in additive, but the one thing that additive does enable that maybe some of the other processes didn't is the freedom to take advantage of design capabilities that are not possible through other methods. And simply converting a design over from traditional manufacturing to now printed in additive is not taking full advantage of it. So the design methods and tools and the workforce training that's required to enable a ground up additive design from day one is paramount to enabling the acceleration and adoption of additive. So that comes with both education for the design workforce, right, or engineers or designers or studio teams, and then the right tools that will enable usability of additive designs across common formats and across the whole digital thread. There's also a lot of business work, right? The integration in the front end of understanding the value proposition and the business case that comes with these designs as well. When to use additive. So the questions that we ask here at General Motors are always, can we print it and should we print it? And the should we print it is a very important question, because just because you can achieve something doesn't mean it's the most cost-effective way or the highest value proposition to do so. So the right tools to integrate into those business decisions is important as well. And not to be lost in all this is the plant floor layout side of things, which is something that's done extensively in any manufacturing industry, but especially automotive. of just laying out your manufacturing facility and planning and right sizing the equipment and the design. And that's no different for additive. So design tools that help enable that will certainly move the needle forward in adoption. The second swim lane falls around materials, right? It's no secret that a lot of the materials available today in the market are heavily geared towards aerospace, defense, or the dental and healthcare industries. And rightfully so. Those have been the low volume, higher margin type industries that have adopted additive manufacturing for production use. And as such, you've kind of reached into this chicken and the egg problem now, where you don't have enough demand to develop the new materials that are needed for automotive, and then the materials aren't there, so there isn't enough demand in automotive in the first place. So at some point, us coming together as an automotive industry, agreeing on what are those materials that are agnostic, that come with the right standards and specifications for material properties that are required, that are open source, fully characterized, and would be used and adopted by the automotive industry. Again, I won't get into all the details there, but there's a brief summary on the right-hand side. As you can see, some of the categories. Polymers, right? Not a whole lot of titanium metals or other super alloys on that list. A robust and available material supply is also key, right? As many industries this year and last year were hit with supply chain issues and material issues that we experienced across the board, being tied into a single source supplier, often the machine OEM, it is not a feasible business model for the automotive industry moving forward, right? It needs to be robust, it needs to be available readily, open source, agnostic. This is what will enable us to be truly efficient in our supply chain and markets. Lower cost goes without saying, right? As the volume of demand goes up, the cost will go down, but continuing to drive that cost of the raw material and feedstock lower will again accelerate the adoption of the additive processes and parts. And of course, just like any other industry, automotive cares very much so about the sustainability and the recycling of our parts, of our components, and our vehicles. So being able to capture the full value of the AM materials through recycling and reuse is. And finally, just touching on again the characterization and validation, the ways in which the materials are assessed, the properties that are required for use in automotive to generate those material cards for our FEA programs, etc. That's something that, again, through US Car, at least the North American OEMs are coalescing around fully to be able to put one standard out there that the machine vendors or machine suppliers can provide. Two more swim lanes to get through here, right? So the next swim lane is around manufacturing and process industrialization. So this is the actual equipment, the machines, the post-processing, the automation that goes into the actual additive process itself. The machines obviously hail from a legacy of prototyping. And as such, there is an acceptance of many things that would not really fly in an automated, modern automotive facility. That can range from anything from the speed of the physical printing operation itself to the robustness of the process, the throughput that you get overall from the process end to end. So that's including the setup time, the turnover time, the post-processing that goes into the components to get a near net ready to take to further downstream operations part. The repeatability, the build volumes themselves to be more in line with some of the parts that automotive would look to print. These are all things that need to continue to evolve to really enable the next generation of automotive applications. And then that comes with integrating into both physical and digital workflows in plants. So interoperable systems that don't create a completely fragmented landscape where every machine has its own software, has its own digital thread and ecosystem to manage on a plant floor that may have 5, 10 different machine vendor OEMs. Most automotive facilities have single MES systems, manufacturing execution systems, and single plant floor control systems that these machines need to start integrating into. And extending into quality control, process control, and testing, right? A 100% inspection method is not really sustainable for any sort of appreciable volume, especially when it comes to automotive. Automotive has statistical process control methods and other process control methods that are deployed to move us away from having to do 100% inspection, and then that similar mindset to be brought into the additive realm and the additive world, whether that's through in situ process control variables that are being monitored, or other after the fact plant floor integrated product quality control and statistical process control methods. The post-processing itself, which can represent a significant portion of a part cost, depending, the machines today will print, but won't be near net in many cases too. There's significant operations required to get the part to even near net, to then take it to further downstream value stream operations, such as finishing through machining operations or any sort of cosmetic finishing. So even just getting to that point where it's ready to go involves significant labor touch point, significant operations, and minimizing that post-processing and through automation, through built-in systems is going to be important. And of course, again, touching on the sustainability and the recycling, the processes themselves being low waste and low emissions. Finally, last swim lane here around operations and workforce, right? The actual talent in the automotive world and then the operations that are needing to be run by that talent it's incredibly important to the adoption. So starting with something like factory connectivity to even just simplify all the manual labor that goes and running a controlled process to enable through machine connectivity, interoperable machine and connection into unified and already existing MES software packages. The safety of the material, the equipment, and then the worker safety is incredibly important as well. Like I mentioned, many of these machines might hail more of a prototyping legacy where certain practices may have been more acceptable and forgiving to allow. But as the usage goes up, right, the incident rates can also increase, the hazards also increase, and just from a baseline level, some of the operations need to continue to prioritize safety, ergonomics, and minimize the operator exposure and touch time during operations such as turnover or filter changes, etc. The maintenance of the equipments themselves, right? At any automotive facility, there's in-house maintenance, there's on-call maintenance, 24 hours, 365 days a week, 365 days a year. That type of mindset and mentality to enable machines that can be maintained by skilled trades, that can be maintained on quick turnaround notice, is important to ensure uptime and robustness in a production factory. And of course, the skilled, diverse, next generation workforce from operators to engineers to executives is going to be needed to continue the adoption of additive and push it forward in the automotive industry for not just pre-production use, but production use as well. So with that, I will draw to a conclusion here. Again, I'd like to thank you for your time and attention here, and we'll move to a Q&A section. And again, thank you to all my US car colleagues that helped pull this together and allowed me to represent and speak on this briefly at the MMX. So with that, I'll stop sharing and switch back to just the Q&A mode. Okay. So I see there's a couple comments here in chat. Can we reuse recyclability of the particles? So Dustin, I see your question here from you, right, on unused raw AM material being reused and a study on the recyclability for fully finished AM parts. There's a variety of studies that have been published in journal articles, so more academic studies, and then some of the material suppliers, especially in metals, have also published their own studies that show different conclusions, right? Some of them strongly stress there's an end use or life to the reuse of certain alloys based on things like in the metal world, oxygen pickup and whatnot. And then others really stress that there can be an infinite life as long as you maintain a refresh cycle that has been approved. So in automotive, obviously, we want to maximize the reuse of the materials and while also maintaining the required quality. I can speak to at least on General Motors side, what we've seen is with the right refresh rates and blend rates, we are able to more or less infinitely recycle materials and continue to do some internal studies on that. But that's certainly one of the things that can be either commissioned or spec'd out eventually through the U.S. car type organization. Okay, I'm not seeing any other questions yet in both the chat or the Q&A.
Yep, don't see any. If anyone does have questions, feel free to populate them. We have a couple of more minutes that we can take up if you have any. And maybe in the meantime, questions. So you talked a lot about just now in recyclability and a lot of metal AM processes in particular. Are there any new or emerging AM technologies that are of particular interest or that you're keeping an eye on, and maybe if there are or aren't, is there any different evaluation process that you run those through, understanding all the realities of automotive? It needs to make lots. I think we've heard that now from you and Ellen. We all understand that. I came from your world and your organization and get.
Mm-hmm. Yeah, so I'll answer in a couple.
Hang on, you just got muted.
Okay, how about now?
You're good now. Yep. And muted again. That's weird.
How about now? Okay.
Perfect.
Good. So first, a bit of a tongue-in-cheek answer, I guess, right? There's a new additive process every single day in my inbox because I'm subscribed to a couple of newsletters. So there's no denying that there will always be a new process, the next new shiny thing. There's certainly many that are of interest, but one of the things, especially in automotive, that we're trying to lock down is the number of processes and the variability that we see. We're trying to hone in on a few key winners early on that drive value for our applications and needs, and really focus on industrializing those first. And then the learnings from those can be carried on into future, applications, modalities, whatever it may be, that we move towards. In every single one of them, understanding the value chain around recyclability of materials is extremely important. Would certainly say in some modalities it's more mature than others, right? There's more of a built-in closed loop cycle, whereas others, there's certainly much more waste generated that needs to be accounted for. And I think all the automotive OEMs have had individual conversations and now through US car with the machine and material providers to change that model such that it's more of a closed loop recycling system. Okay. Let's see here. There's a question on value chain resiliency. So I'll answer that from the chat and then jump over to the Q&A. So how do you integrate AM and the concept of manufacturing resilience or value chain resiliency? So a couple ways to look at this. The first can be through low volume fragmented manufacturing, right? There's often challenges in bringing those types of vehicles and products to market because the unit volumes can be so low. Our traditional supply base is not as much interested in pursuing those. Or if you go to a smaller shop that traditionally does not support automotive, there's risks in the supply chain there as well, with suppliers exiting businesses and whatnot. So additive manufacturing can step in and provide a production solution there that can easily be transported between suppliers as long as you have a controlled process that's in place. The other way can be around service parts as well, right? Oftentimes with 5 to 15 plus year serviceability requirements for parts for our vehicles on the road, you're looking at anywhere from a few years to 5+ years of production, then another 15 years to end of life of service. Some of those suppliers can go out of business, or a tool can be lost, or anything can happen. Service go up. Additive manufacturing could certainly step in there as a business solution and a technical solution for those components and maintain a supply chain of service components. And finally, in events, those once in a lifetime events that seem to happen once a year now with COVID and shipping issues and whatnot, additive manufacturing can always be a bridge solution for production while we're waiting on a more mainstream solution to come in And at least speaking for General Motors, in all three of those categories, we have used additive for that very purpose. Okay, so I'll switch over to the Q&A now. So Peter had a question on what is the interaction between the U.S. car team and the AMSC and NC on moving these roadmaps forward. So I think there's been somewhat limited interaction on those, right? I think the U.S. car team has certainly benchmarked what the AMSC and NC have done on the roadmaps and translated some of those needs into ours. I think there's further opportunity for closer collaboration, especially when it comes to the execution phase, where industry and OEMs are partnering together to address some of the needs on the roadmaps. And there possibly are a lot of synergies that can be done that are agnostic of automotive, aerospace, etc. Question here, given the goals of limiting variability, recyclability, etc., do you believe this will be realized through process optimization or new material development? I think a lot of it is going to come through process optimization, right? Even the current materials today, as long as you can develop an in-control process that's fully understood, characterized within the limits of variability you expect to maintain, you can use today's materials. There isn't necessarily a need to develop new materials with inherent, lower variability in some dimensions, because there may be some other unknown dimensions that it has greater variability on. So in automotive, a big part of our quality management systems and launch processes is fully characterized process and process controls and process control documents, no different than what aerospace or other industries may have. And it all comes down to fully understanding your process and optimizing it. Okay. Is there more prospect for improving post-processing techniques or producing more final surface quality out of the machine? I think it goes a little hand in hand, but the preference from some of the automotive conversations that I've been having is out of the machine surface quality or out of the machine reduction in post-processing, to put it in a better way, is preferred. Because more post-processing techniques or different processes increase the amount of equipment, increase the amount of processes that you need to control. So having a certain baseline of near net parts coming out of the machine that has a minimal amount of post-processing is the first preference. But certainly the right tool for the right job, if it's not being accomplished in one machine, then using the right post-process equipment is the way to go. And with just a minute left or so, I'll take one last question here from Todd. As a new startup with new meta technologies, how do we get in touch with people who understand our meta technologies? Sorry, this is a basic question. So with meta and immersive technologies, that's not necessarily my domain as it comes to additive manufacturing, but General Motors certainly is looking at immersive technologies, as are all the other OEMs as well. So there's certainly opportunities to get in contact with our communication staff and continue from there. Yeah. So I think with that, John, we'll probably call it a close with a few seconds left to 1:30 and give people time to get to their next talk.
Yep. No, perfect. Appreciate it, Ollie. I think that was fantastic. Good follow up to the panel that we just had. So really talking through, somebody putting it into action and specifically in a particular industry putting into action. So thank you, sir. I appreciate your time and your information share.